So currently, we're lacking legal security when it comes to critical data. My name is Tim, and I'd like to talk with you about how to establish proof of data validity. Data is the foundation of our digital future. However, we have invalid visa because the extension process takes too long. You can buy vaccination certificates via Telegram, and the World Bank Group had to discontinue their ease of doing business report in 2021 because of data manipulation. And all of that happens, although we know that paper processes aren't scalable, media breaches are being exploited, and data can be manipulated or misrepresented. The digitalization is without alternative. However, the incentive to fake data scales across all sectors. So we're getting the ESG reporting, we have the e-government, and we're introducing the digital product pass. Of course, there are already different best practices trying to solve this challenge. On the one hand, there are digital signatures, but the problem is they're only as trustworthy as the signee himself. We also have private blockchains, but they're very expensive to operate and they only scale to a limited degree. We also have the digital identity and SSI. This, however, is typically focused on the identity credentials, but not about data sharing itself. Then we have public smart contracts. However, those contracts are based on a public community adding additional complexity with code on top of that infrastructure. And of course, we have timestamping, where, we can ensure data integrity, but it will remain valid forever. So since at least 3 out of those 5 examples are based on blockchain, let's take a closer look. So blockchains are essentially a jointly trusted infrastructure where trust is established by having everybody participate in the operations. However, they typically fail to scale because of their complexity. So on the one hand, we already have challenges to align data formats. Now we want to align decentralized governance. We have complexity of interdependencies between the participants. So how do we allocate cost of innovation? Who participates to what degree, and how much can they expect in return? We also have the complexity of operations, because either you have the skills and resources yourself to be part of the operators, or you have to trust in the skills and intentions of those operators. And last but not least, there's also the complexity of establishing trust, because on the one hand, you need either authorities to guarantee for the trust, or you need to reach a true decentralization, which is very hard in a B2B context, because we always need somebody to hold accountable if something goes wrong. So if we look at the core of what blockchain in many cases tries to achieve, it's to create that immutability, to build trust for collaboration. And if we look at it from that perspective, there are basically 2 aspects. On the one hand, we have the blockchain cryptography. So all of those blocks are chained in a way so that if you trust one of those blocks, you can trust all previous blocks, because the only way to change it is to rewrite the entire series. However, since of course everybody can rewrite the entire series, we're decentralizing the infrastructure so that no individual actor can do so. However, why do we have to write all blocks in coordination with all stakeholders? Doesn't that cause exactly that complexity? And on the other hand, if we already have different trust silos, like authorities, but also established blockchains, why is everybody trying to reinvent the wheel and build trust for himself? Can't we simply go and connect, basically, or publish our results decentrally? So our approach with Cryptar is to combine the best practices of the different worlds. So what we're saying is run the processes as they currently are. Stay with your current data lifecycle. Use established identities and signature mechanisms also use future identities like EIDAS. However, now we go there and say, we don't just sign data, we sign data the moment we write it, we update it, and when we delete it. This then gets published through a cryptographic notary, which only shares the fingerprint. And we publish this to established trusted locations like authorities or different blockchains. And through this, the sender of the data can maintain control, while the recipient can verify the data for himself. So let's look at an example. If I want to share data as an organization, I send it to my users. It's either in JSON or PDF format, for instance. So now those users can forward it digitally, or they could even print that information. In many cases, we also hand the data to processes where they're automatically being processed. Or in other cases, we're also leveraging blockchains to share the data. However, if somebody now receives that information, he doesn't know if it's still true. So he has to trust on the one hand in operations. On the other hand, he has to trust the data entry itself. And here also blockchain doesn't make the massive difference because we still need to trust the operations. Yes, we can participate in the operations, but for that we need the skills and resources. Therefore, of course, we have digital signatures, which we can leverage to sign the data, and by that add validation info to the metadata of our information. For this, the recipient can verify that the data is unchanged and doesn't have to trust the operations that much anymore because it's still the same format as the original sender had it. So we can ensure that the signature can ensure for us that we have data integrity. And through QR codes, we can also enable digital processes. However, we always need a digital identity in order to be sure that the data is also authentic, so that the true owner has published that data. The problem which we have with that, however, is that all the data or those keys have a predetermined validity. So the only way, in case we need to correct data or something went wrong, we can devalidate the key. But it also means we devalidate the key publicly, and everything we've ever signed with that key is invalid. So we have no real controls about that. If a key is being stolen, we won't see that. So data manipulation, if somebody has our key, will only get noticed once we see the result within the data, or that's noticed, not the signature process itself. And of course, we have no proof of timing. So the author of the data is able to rewrite it as often as he wishes without us being able to verify when the data was created. With Cryptar, we take the standard process and integrate the cryptographic notary, which on the one hand enables us to redact information while maintaining the validity of the original data set. Now, we don't need to devalidate the entire key, but as I said earlier, we sign the data also when we update or delete it. And we publish a summary of those signature activities decentrally at a trust anchor location. So now, if we want to devalidate data, we can do that for every single signature we've performed. And we can control the validity of our data after sharing, regardless if it was phygital or digital. Additionally, we're also receiving evidence of our signature history in case we're getting any disputes. And we can detect if somebody else is abusing our key, because now we have a local reference of our signature history and we have a published history. If there's a discrepancy between those two, we can proactively react and start revoking our data, which is being signed by somebody else. Through this, we also get a legal evidence for the data validity and the timing of our data. And we can enable automated data cleanup. One of the clues in here is that we're able to really consolidate the entire signature history within each single hash. This enables us to also publish this data or the fingerprints asynchronously. So on the one hand, we can publish it to authorities and trust service providers like TÜV, D-Trust, or even a governmental agency. But we can also asynchronously publish the same verification on permissioned blockchains like ID Union or even any local Hyperledger implementation. And if that's not enough to scale the trust, we can also go to public blockchains. And we can use all of those simultaneously without having to build the trust ourselves. So we adjust to exactly the needs of the user to establish that trust. And by this, we can control the level of decentralization. So if we look at an administrative or industry process, for example, we can use this to also integrate certifying authorities. So in case we have sensitive data where we're too afraid to share that across the supply chain, we can have an authority essentially attest to us that that data conforms to standards. We can redact the critical information, send it onward, and every recipient can verify himself that the data is according to the standards based on the attested. We can also integrate that, of course, within the industry processes or at edge devices in order to secure the data where it's being produced. And then we can also build additional trust services around that in order to feed the users, but also to enable extended use cases. So we can take the same data, integrate it into NFTs. We can also control the integrated data if it's in different systems. And of course, we can redact and share the data with different users or stakeholders. So what we essentially do is that Cryptar expands digital identities with trust into the data validity. So we have the digital identity, and we at the timeline being able to mathematically verify data validity. I'm saying validity, not integrity, because we can tell when was the integrity verified and was it ever revoked by the author. We can decentralize that verification based on the user needs. So we always need to look, what does a business really need, rather than having to build a global decentralization if we have a local trust center anywhere. We save a lot of money in operations, because now we're just talking about a simple API or integration rather than building a parallel infrastructure. We're planning to release this as a subscription-based model. And of course, it's zero trust extension because no real data is being shared with the service. We're only talking fingerprints here. Through this, we can enable trusted collaboration because the owner of the data still maintains control, can evidentially devalidate data after sharing. So there are no version conflicts in front of courts anymore. We can proactively detect signature abuse, and we can also minimize the risk from must-know sharing. As a data recipient, we can build trust, because on the one hand, we can prevent insecurity based on versioning, but we also can protect data input-based decisions in order to being able to justify ourselves in front of courts if we took automated decisions based on data we got delivered by somebody else. And we can scale this process across multiple trust silos, because we don't expect a lot of architectural complexity from the participants. Same is true, of course, also for authorities or trust service providers. And we can add, change, and adjust trust locations as we need. Because even when we look at public blockchains, they may be very decentralized and very secure, but also their features change over time, and we need to keep track of what's happening.